Hi, my name is Gyarados, and welcome to Redstone 101, a video where I'll teach you the basics of Redstone and teaching methods I use in my class. Minecraft is an important tool to teach because it introduces students to 3D worlds, mechanical engineering, electrical engineering, and computer learning, also while making it fun for the students. So today I'm going to teach you how I teach my students the basics of Redstone. This lesson is usually the second lesson I teach in my session. The first lesson would be building a house. So I like to let students mess around, get excited about playing Minecraft. Minecraft is fun. Get them used to the controls. Most kids never played on a computer before, so using the WSA key, the keys are weird to them. So just have them build a house. That's a very good first lesson, and have them get comfortable using the computer. And what you need for this lesson is the student to be able to move, access their inventory, and know how to break and place blocks. And I do this by using a map I made on Minecraft, which you can find in the teacher folders on Google Drive, and do the same thing I do. I came up with this method of teaching because it saves me time. I have this map available to me to quickly demonstrate to students all the different types of redstone. There's a bunch of redstone, and this map makes it easier to teach. It saves me time, and it saves you time as a teacher, and it gets the students thinking more. Making a bad first impression is a very common mistake. The way you present yourself during the first class is how the whole session is going to play out. If you go in there and let kids disrupt you, they're going to disrupt you not just that session, not just that class, but every class following. Hello class, today we're going to learn about redstone. Does anybody know what redstone is? Yes. Yeah, you're right. Redstone is electricity in Minecraft, pretty much. Can you guys point to anything that runs on electricity in the room? Make sure you just stay on top of it. You don't need to be cruel, but be firm. Minecraft's a game,
Yeah, the lights were on.
and kids think it's a game.
Yeah,
They
the
don't want to
TV
learn,
also
they just want to play around.
Good job.
So if you let them play around, they're not going to learn. Yeah, a lot of stuff in our lives run on electricity. And same thing in Minecraft. When teaching Minecraft in front of the class, make sure to use real-life examples, make the students think critically, and engage with them. Ask them questions. So we're going to get started. We're going to go to this world right here. So here's my Minecraft world, and I'm in creative. So I'm going to pull out my inventory. And lucky for us, there is a tab dedicated to all things redstone. Right here, redstone. And all this stuff here is related to redstone. And we're going to go over these things right now. So what is redstone? Does anybody know? Yes, AJ, what is redstone? Yeah, you're right. So redstone comes in an ore, we mine it, and it drops redstone dust. And we use this redstone dust to build whatever we want. So I'll pull that out right now. I'm going to click the compass, and I'm going to type in redstone ore. Yep, redstone ore. Redstone is essentially electricity in Minecraft. It helps us build tools and automatic machinery. Here it is. So here's my redstone ore, and I'm going to place it down. So we can mine this ore with an iron pickaxe and a diamond pickaxe. Any other pickaxe won't work. When we mine it, 4 pieces of redstone dust will drop, and we use this to create stuff. So one misconception is that redstone dust is the electricity. That is not true. So in real life, we have streets, we have roads, and we have cars that drive on these roads, right? Cars can't drive in the ocean, they can't drive in the sky. They can only drive on the road. And same thing with redstone. Redstone dust is the road, while electricity is the car. And we'll see that right now. Let's pull up some redstone. So I have my redstone dust. This is how redstone dust looks like. And if I put it in my hand, I can place it on the ground. And I made a wire there. All I have to do is right-click the floor with it in my hand, and it will automatically connect to itself. So right now it is dark red. It has no power. To power it, we need to get a power source. And there's multiple different kinds of power source, each with its own unique use. So we're going to go over this real quick. First power source is the redstone torch. And it's unique because it is continuously powering the redstone. As we see, the redstone is lit up, but it will always stay lit up until I break this torch. So when I break it, the signal turns off. There we go. And we're gonna move over here so we can better demonstrate this. Right, we have my torch, and it's constantly powering up the piston. Next to it, we have something new. This is called a lever. A lever is very similar to a torch. However, it is always on or always off, but we can control it. So if I right-click the lever, I can turn it off or on. I cannot do that with a torch. The only way to turn off a torch is by breaking it. The next power source we're going to go through is the button. The button is also very similar. I will right-click the button, and it will turn on the piston for about 2 seconds, then shut back off. So it is on for a brief moment in time, then it turns itself back off. So those are the three main types. There's a couple more. We have a pressure plate, redstone block, daylight sensor, observer block. These are the main three that we should focus on. The rest are little extras, and we'll go over if we have time. But for right now, we'll go over the pressure plate. And as we can see, nothing has happened. The way pressure plates work is, if an entity steps on the pressure plate, it will activate a redstone signal. So if I, the player, or any other object, such as a zombie, a pig, or anything that moves in Minecraft, stands on this pressure plate, it sends out a signal. Very useful. Next one is a block of redstone, which acts just like a redstone torch, but we can actually place stuff on it easier. You can still place stuff on a redstone torch, but this gives us more surface area. And it's always on, like a redstone torch, or always off. I have to break it. And the next one is the daylight detector. And I like to think of this as a solar panel. If it's light, it powers up. Right now it is yellow, so it's in day mode, like the sun. If I right-click it, it turns blue, and then it turns off. It is in night mode. So I just inverted it. So now, when it's nighttime, it'll send out a signal. If I right-click it, it turns back to daytime, it sends out a signal. This is very useful for alarm clocks or anything that is on a timer. And the final one we're going to go over today is the observer block. So, does anybody know what the word observe means? Max? Yeah, you're right. Observe means to see, to watch, right? And if we look closely, this block has a face on it, right? 2 eyes and a little mouth. So what this block does is it observes, it watches, if we place a block in front of it or if we break a block in front of it. If we do one of those two things, it's going to send a short impulse of electricity behind it. So we have to be careful when building with this block, because we have to place the redstone directly behind it. You guys see this little red circle? That's its outlet. And we have to connect redstone behind it. So I'll demonstrate this right now. I'm going to place a block in front of it, and this redstone should light up briefly. There we go. We saw a short little flash. I'll break this block so you guys can see it again. Pay close attention. 1, 2, 3. There it goes. It's a short, brief flash. And this is very useful when we're building things that change, like a sugarcane farm. So now those are the main power sources. We're going to go over a couple redstone physics in a second. And I have this beautiful map built out for us. So we already did that. So our first example is this little piston right here. We have our power source, we have our wire, and we have our piston. So my question today is, if I push this lever, will that piston light up? Raise your hand if you think yes. Raise your hand if you think no. All right, moment of truth, let's find out. No, it did not light up. And that is because it is not connected. If we look closely at the piston, this redstone is not touching the piston. So it is not powering the piston. One way to fix this is by breaking this redstone there. Once I break that, it automatically connects to my piston. This is called looping. We have to be careful when building. If I place a redstone dust next to another one, it automatically loops and it cuts our connection. So be careful when building. Our next one is this guy right here. Let me fly up so you guys can see. I have my power source, my wire, a block, and then my piston. And once again, do you guys think this will light up? Yes, no? Okay, let's find out. So if I push the lever, let's see, it lit up, right? You're wondering why? Why did it light up? There's something in the way. You're right, there is something in the way. But look, this is the power source. It's sending electricity to this block right here. This block is full of electricity, and the piston is touching it. If I stuck my finger in a power outlet, what happens to me? I get electrocuted, right? And let's say I touched you while I was being electrocuted. What happens to you? You also get electrocuted. So think of this the same way. This is full of electricity. Whatever touches this one block here will also be full of electricity. And let me place a piston so you can see that. So if I place it on top or the side, it will also be powered. There you go. All right, this one is very similar, but we're missing something. We're missing the wire between the lever and the block. Will this work? Let's find out. All right, it worked. I didn't have a wire though. Remember, the wire isn't electricity. The wire is a wire. I don't need a wire to power something. So, same logic as this one. This is the power source, making this full of electricity, thus powering our piston. So now I have a staircase, my redstone in a staircase, and a piston at the top. When I pull this lever, it will turn on. So you're wondering how I did that? You're wondering how I put redstone on the side here? Well, you don't need to worry about that, because once you place redstone on top of a block, it will automatically connect on the side for you. So don't need to worry about that. Redstone staircases like a normal person walking upstairs. However, if it's 2 blocks high, redstone can't climb that high. So it has to be 1 block at a time. Next one is very similar, but we're going to add something to it. We're going to add 1 block right here. And I'm going to push this lever, and let's see if this works. So I push my lever, the piston isn't going. That is because this block is severing the connection. You see how there's no block on the side here? There's no redstone climbing up here. It's because this block is cutting this connection. To fix that, all I have to do is break this 1 block, and it gets connected automatically. So when we're building, we have to be careful not to sever the redstone connection. Okay, so this one's a little tricky. It's a little weird. So I have my power source here. I have the redstone wire down here, and I have some redstone a block above it. Will this turn on? Any guesses? Yes, no? Okay, we'll find out right now. So when I push this lever, the top does not light up. Okay, cool. Now we have the opposite. We have the lever on top and the redstone on the bottom. And this is a little weird. Look what happens when I push the lever. The bottom one lines up, right? That's not these two look very similar, but something's going on here. So let me explain. It's better if I go to the side. So on this here, this is the power source. This block is full of electricity, and it looks like we have air here, right? Look, the redstone is not touching the block. But in reality, this one little piece of redstone is taking up this whole square here. So this block is full of electricity, and it's powering this block that's taking up this whole square here, and it's transferring it down the wire. If we go back here, it's not doing the same thing, right? This redstone is touching this block. This block is full of electricity, but the electricity stops there, and it does not power the next one. Electricity can only go 1 block away. The next thing I want to talk about is how far redstone signals can travel. So here's my power source. I have my wire and my piston, but look what happens when I push the lever. It sends a signal, but the piston's not on. And if I walk towards it, I can slowly start to see that the power is getting weaker and weaker, getting darker and darker, until I get to this point right here. And this redstone's the darkest, and it's not sizzling. We don't see any particles coming out of it. That means the power signal stopped right here. And if we counted all these redstone squares, we'd get 15 blocks. Redstone can only travel 15 blocks away. So what if I have something that's more than 15 blocks away? Well, I have a solution. It is called a repeater, this guy right here. So now, when I push the lever, the piston turns on. This repeater acts similarly to a power outlet, extension cord. It extends the signal. But we have to be careful when using these because they must be placed in a certain direction. If I fly over it, you can see a triangle. And this triangle is pointing to the direction the current must flow in. So our current is starting from down here, it's traveling upwards. So our triangle must point upwards. So the direction of a repeater is very important. So make sure that arrow is pointing in the right direction. Also pinching, make sure that no blocks are cutting the circuitry of the redstone wire. So a good trick is to, if there's a problem with a kid's redstone thing, is to start off from the power source and slowly work your way to the end. And you can do that by breaking blocks and placing blocks, but that is a good troubleshooting method. If it points in any other direction, example to the right or backwards, it will not work. There we go. So be careful when using redstone repeaters. This is the number one problem I get with students in redstone, is when they put the repeater on backwards. So that concludes our redstone tutorial. But before we go to our next lesson, I just want to briefly show you our future projects, what we're going to learn with redstone. So right here I have a clock and it's off right now. Let me turn it back on. To turn it back on, all I do is break this torch, place it down, and see how it starts flashing like a disco ball? The power is just looping and looping and looping and looping until it burns out. So we just learned about repeaters. Repeaters also have another purpose. They act as delays. They make redstone signals go slower. And you can see the signal goes this way, slows down. It's much slower than the one before it. So what can we do with clocks? Well, we could add stuff to it. So right here I have a trampoline. It is off. Let me turn it on by placing this torch on the side here. And there we go. I'm not doing anything. It's automatically going on and off. And we're going to learn how to do this after our lesson. We could also add clocks to a command block. Here's my command block. I don't know what's inside this command block, so I'm not going to power it. I'm going to leave it off for right now. And other things we can do with redstone are logic gates. I have a couple here, and we can use logic gates to build secret entrances. I have a secret door here that goes underground and is only connected to one power source. So here's my logic gate. When I push this lever, 2 pistons behind these pillars will open the dirt. There you go. I have a secret entrance because of logic gates. This is how it kind of works. This is called a NOT gate. So we can see here that the redstone torch is powering these pistons. These pistons are constantly on. With this type of gate, I can invert the signal. So when I push this lever, it turns them off. So when this lever is on, the pistons are off. And when the lever is off, the pistons are on. After I finish teaching the students about the distance redstone can travel, I have them implement all that they've learned so far into their next project. This could be lighting up a house they've built previously, or a new project such as lighting up a spaceship or automating a pirate ship. It is up to you as a teacher to figure out what to do next. All right, so now that we know about all there is to know about redstone, we're going to go on to the next lesson. So you guys just finished building your house. Now we're going to light it up using redstone. And you guys are going to do this all by yourselves. I'll be here to help, but this is on you guys, okay? All right, get to it. Go. I recommend having students work by themselves. Oftentimes when they work with other people, they like to fight and mess around. Playing by themselves makes them focus on the activity. There's a lot of good maps I have available on the Google Drive that are also very self-explanatory, where you'll just explain at the very beginning and have them complete the project. A good example is the roller coaster map that I made. I get students to think creatively with redstone by making them build projects that they will use in survival. So that way when they're done with the class, they can go home and use what they learned at home. If you repeat the same class over and over again, they're gonna get tired of it. So I recommend going on YouTube. There's a bunch of cool stuff on YouTube. Look how that works, try to implement it into your curriculum. Building a basic clock is a good way to start with redstone. I also encourage you to build a house and light it up using only redstone lamps. It's a lot harder than you think. Thank you for watching this video. Hopefully you've learned the basics of redstone and how to teach it. Always remember to practice out a lesson before you teach it, and good luck.